Okay, we went over some of the general concepts of overlay analysis of vector data. Next, I want to talk a little bit about some of the specific tools in the software we use in lab called ArcGIS Pro. And these are separate tool sets or toolboxes that contain different sets of tools that we would use for overlay analysis. We have the extract toolbox. This lets you select features and feature classes based on spatial or attribute information and extract them to a new feature class. We have the actual overlay analysis tool set, which does things like intersect and union, pairwise analysis. We'll get to that. Proximity is about buffering and telling if things are near one another, and statistics. So we'll take a closer look at some of these tools here. The extract tool set, we won't go through every single one, but the two basic things are we can clip or we can split. So clip, where you have an input layer and you want to just clip out a certain area. The clip feature or a whole data set can be a clip feature that can be used to chop out, kind of use your one data set as like a big cookie cutter to chop out or extract a piece of another data set. We can also split it up. We can have zones that are used to split an input data set. So like a whole set of cookie cutters at one time that then splits it into separate data sets. So clip and split. Before we move on, one other thing and that we recently found useful for something somebody was trying to do, you can also split by attributes. So if let's say you had a data set of separate map sheets, like let's say zone 1, zone 2, let's say you had this here, and you wanted to create a different data set for each of these zones, a separate, not a combined data set, but a separate data set, because one example I've seen recently is somebody needed to upload a shapefile to a website to get soil information. And so what they wanted to do is take each of their features and create a separate shapefile, separate data set that they could then use to upload and interact with the website. So you can actually split by attributes and it'll create separate data sets for each of these zones here. Okay, overlay analysis. And here is a better view of the difference between the three. These are like the three, you know, when I went to school in 1990, when I took GIS class in 1993, we learned the exact same thing. This is the kind of the core tool set of GIS. And you know, when we were typing command lines, we would have an identity command and an intersect command. We had to learn that. So it's good to see it in a kind of an illustration. Here's identity. Now we have the identity feature. It's used to add attributes to the input feature, and the output you get is the output including the stuff that's been identified. The input is the limit of the output. The identity feature is just kind of a tool to add information, but we take the input and what we get is the same boundary as the input is in the output. The intersect, however, is only the output is the intersection of the two. We have the input and the intersect feature, and we only get the overlapping area. The non-overlapping area goes away. Union, on the other hand, is more expansive. We get the union of both the input and the output and so these kind of all do the same thing. The difference is in the output you're going to get. Do you want your output to be the same as your single input layer? Do you want it to be only the intersection of the two, or do you want it to combine the whole union of the two input layers? Identity, intersect, and union, differences in the output. Some similar tools include update. So let's say you had an input layer and you say it was a land cover layer and you had some newer land cover data for a certain subset of it. You can use that to update, to kind of to update part of your data set with new data. Symmetrical difference, where you take two data sets and you remove you erase the areas of overlap between them. So here this area that's overlapped goes away. You can count overlapping features. So here we have 3 overlapping buffer zones, and the output can be, here you had 2 overlapping features, here you had 3, here you had, and so on. And I'm trying to think of, I know I've used this before, I'm trying to think of a good case use, but when you know it, you just need to know that you can do this, because one day you might need to do it for whatever reason or another. So know that it can be done, and one day you're like, boy, I wish I knew how to, how to tell how much overlap there was between these 2 features. Oh, count overlap. Erase, kind of simple concept. It's kind of the opposite of clip. So you have an input feature, the erase feature erases part of your input feature. Okay, proximity tools, including good old buffer. You can have points, lines, or polygons. You can have no dissolve, meaning that they can overlap each other. You can have separate buffer polygons and they can overlap of points or lines or of polygons. Or the dissolve. You can have a dissolve where the things that there's no overlap, that things just meld into one another. You can do a multi-ring buffer where you can have, 10, 20, 30 meter buffers simultaneously. There's something called Thiessen polygons where you have a set of points and it creates a set of polygons that try to, I forget the term for it, but it is to kind of evenly allocate these polygons to the points, so that each point has its own sort of polygon feature that is created to kind of evenly represent the points. Actually, I had to go look that up. I paused for a moment. So here's the deal. For each of these polygons, everywhere in this polygon is closer to this point than it is to another point. And that's how the Thiessen polygons are created. There's the near command that actually calculates the distance between features. You could have, lines near polygons, near points. That one you might need to read the help on for a minute. It's not quite a simple concept, but it can calculate what are the nearest features to other features. And polygon neighbors. So for each polygon, you can calculate whether it's the ones that are adjacent to it. Okay, so going back to just to give some examples, why would you want to use one tool or another? Let's say clipping. You might want to clip a smaller area to study. Let's say you really want this smaller area to work on. You could use a polygon layer to clip out your study area. So simple concept. Point and polygon operations. Well, you might have samples at 6 field sites. You might want to know, well, what is on the soil map, what is the soil designation at each one of my field sites? You can do an overlay operation that transfers the soil information to the point features. So here you have your A, B, C, D, E, F sites. And now for each one, you have the soil type added to it with the point and polygon operation. Erase operation. Let's say we need to exclude something from our analysis. So let's say we're doing some type of a operation where we want to do a site selection where we're trying to select a site for something. The power plant can't be included, so we just erase the power plant from our analysis. And what we're working towards is something called suitability analysis. And suitability analysis. And so some examples include habitat suitability analysis, this is something I've worked on a lot with biologists to try to do GIS operations to identify what are the good habitats for certain species. This could also be applied to business, like what are the best locations to open a restaurant or a delivery operation or what have you. So essentially you're identifying, what are the positive traits and the negative traits. So the good, let's say, what you're trying to do is find areas in my study area that are less than 200 meters from primary roads and less than 250 meters from any type of water. So how do we approach this? Well, first we want to be 200 meters from primary roads. So we use buffer. So here the buffer comes in handy. We create a 200 meter from primary roads. So anything within this buffer meets that first criteria of being 200 meters from primary roads. 2, less than 250 meters from any type of water. Okay, so we create a buffer on the water features. So now we have an area that's 200, the polygon of 200 meters from the roads, a polygon of 250 meters from water, and where the two overlap, we can use an intersect operation to overlap these two and only get the overlapping area. Now this is our things that have met our criteria. This is a suitable place for whatever it is we're trying to do here. We can also exclude things as well, like the bad. Let's say we want to exclude water features, areas less than 150 meters from railroad tracks, or 75 meters from power lines, or 200 meters from a borrow pit, which is some type of feature that we don't want to include. Okay, so we take all of the exclusion features and we can create buffers around them. And let's say we can union together all of the unsuitable areas. So here we have, these are all the things that met the bad criteria. And we have, and then we can combine that. We can use that we take our, our data set, which was the good, we can erase out the bad, and these are the suitable areas that are left. So let's kind of walk through that again. So let's say, and this is called a model builder. So in GIS, including ArcGIS, you can actually, instead of just doing these one at a time, you can actually chain together operations in what's called a model. You can visually build and connect together these commands. And that's when you're really cooking with gas, when you can kind of create these complex models of operations to really do what you want. So find areas of my study that are less than 200 meters from primary roads and less than 250 meters from any type of water. Okay, so we have, we buffer the roads, we buffer the water, we intersect those two. This is the intersection of the road buffer and the water buffer. This is our good stuff. Okay. Next, we want to exclude information. So we have our water we want to exclude. We want to exclude the train buffer. We want to exclude the power line buffer. And we want to exclude the power line buffer. And then we can combine all those together into this big bag of bad, the stuff that we do not want to place our sight on. All right, so this is the good stuff. And then from the good stuff, we can erase the bad stuff, and then we can have what's left. This is the good areas that we want to keep. Simple example of suitability analysis. That's the end of the video. Thank you.